So the plants you see behind me are small young seedlings of a plant that's known as Artemisia annua. It's also known as sweet wormwood or annual sagewort, and some people even refer to it as sweet Annie. It's a medicinal herb that originated in southeastern Asia and has been used in traditional Eastern medicine for hundreds of years.
How I originally became involved is I met a gentleman named Peter Seeberger, who is actually the director of the Max Planck University in Germany. And he was in town actually setting up a collaboration with the Kentucky Tobacco Group. The drug for treating malaria comes from this plant. What Dr. Seeberger did and his colleague Carrie Gilmore, also from Max Planck, what they did is they figured out a way of getting the drug out of the plant. Because historically you have to lay it out in the fields and let it dry, and so whenever there's any weather problem you can have crop damage.
Current global production practices are relatively primitive. Everything's done by hand, very labor intensive, very small scale. So they were very interested with Kentucky's history in tobacco production and industrial hemp production, that a transplant system for Artemisia annua would fit the bill in our climate quite well. We start off with raw seed. We seed trays. There they grow for about 30 to 35 days, and then they're transported to the field and transplanted with the exact same equipment that a tobacco farmer would have on hand. From there, the crop is managed until the optimal harvest time is determined, and that's when the pharmaceutical content within the leaves is at its highest. Once the plants are cut, they are then dried, and those leaves can be used for extraction and further purification of purified pharmaceuticals, or also blended with coffee or tea as consumable beverages to be consumed right away. So this plant biosynthesizes compounds that have been in the past and primarily used for the treatment of malaria. The two of interest are compounds called artemisinin and dihydroartemisinin.
So the artemisinin is the active ingredient, but it's not very stable once you get it out of the plant. And so a chemical process is used to convert the artemisinin into artesunate. And that makes it more like a drug. You can make it into a pill.
Ovarian cancer is a difficult disease to treat. It presents typically in advanced stage where survival rates are not as good as early stage. And as such, we have difficulty with recurrence and resistance to chemotherapy agents. Artesunate has been studied in the lab, Dr. Kolesser's lab, by her group and our GYN oncology group against ovarian cancer, and it shows pretty significant cell kill in the lab against ovarian cancer cells, not only just chemo-naive cells, which have not been treated yet, but also cells that have become resistant to standard chemotherapy. So that's the exciting part. It seems to be dose dependent as well, so the higher the doses, the better the cell kill. We're looking at what doses are safe, so we start with a phase 1 trial. It will be given to patients who have completed their primary therapy, which is surgery and cytotoxic chemotherapy. And frequently, there'll be a phase of observation where there's no active therapy being given. And that's a trying time for patients. It is difficult to just watch and wait sometimes.
So we had the idea of giving the tea and coffee once or twice a day to patients who are not getting any active therapy to see if it would prevent a relapse. It's kind of a similar situation in AML. Once a child is treated for their AML, they just are followed over time to see if their disease recurs, and they don't get any active treatment. So our idea there, also based on in vitro work in the laboratory, showing that it had anti-cancer activity against cell lines of childhood AML, we had the idea of using in children to see if it would prevent a recurrence of AML. Investigators in China assessed the Artemisia annua extract's antiviral activity against the original SARS-CoV and showed that it had good antiviral activity again in the laboratory. And so Dr. Seeberger was building on that work and tried out the extracts against the current SARS-CoV-2, and again showed good activity. Based on that, and again its good tolerability profile, we decided that we would test it in patients who have COVID. We've been studying in the laboratory for 2 to 3 years. It's really exciting when something that is promising in the laboratory is actually promising enough to take into a clinical trial. We're uniquely first because we're the ones who were studying it in the laboratory, and we're the ones who are growing it in Kentucky. It is truly the dream to take a plant from our fields to our laboratories and then to patients and potentially help them.
I'm a sixth generation Kentuckian, and all of my father's side of the family had been growing tobacco for all their lives. There's a lot of producers out there, small farms, especially here in central Kentucky, who have lost a cash crop opportunity that you would see in tobacco. So what we've done here is developed really the world's first scalable production model that we can use American technology, intuition, and know-how to really scale this up pretty rapidly. And we, as American farmers, Kentucky farmers especially, are very prepared to make that happen, which would then hopefully in the future mark Kentucky as maybe the epicenter of Artemisia production in the world. It's my hope that with good news from the clinical trials that are ongoing here at the university, that Kentucky producers will be able to take what we've learned and actually grow a crop that could really make a difference in not only their lives, but in the community and the world as well. And that's my dream, is to really make this work. And to be honest with you, I haven't really believed in something as much as I believe in this in a very long time.